Okay, good morning, guys. Hope you're all well. Welcome to summer in England. Well, I suppose it is September. It's supposed to be autumn, but it's freezing, or at least I'm cold. Right, so today we're going to do cluster recovery in my way. Okay, I'm not. There are lots of ways of recovering a cluster, and from a complete disaster. There are many ways to do it. I'm sure they're all wonderful, but this is my way of doing it. I feel it's, for me anyway, it's the best way. It's predictable, simple, and wonderful. Okay, so I know what you're thinking. You're thinking, I've got a 5 node cluster. Why on earth would I ever need to recover it? I've got 5 nodes. I could lose 4 of them, and I could still recover from that single node. And that's true, actually, completely true. So if you have 5 nodes and 4 of them explode, get burnt down, whatever, as long as you've got 1 node left, you can recreate the other 4 nodes, the missing nodes, and you can do it easily. Basically, you simply go out and buy new hardware, install Proxmox, and then simply join them to the cluster, and Bob's your auntie. So you're back to where you were before the disaster, except for one thing. In today's climate of trust and safety, what about a ransomware attack, or just a malicious attack, or human error? What about somebody as administrator on the cluster doing something, I can hardly think what, but to destroy the entire cluster? But it could happen, so you have to have a plan for recovering your cluster in the event of a disaster. And if this is a production network, you know, it's on your head. If it all goes wrong and you lose your cluster, they'll come to you, and you're the one who has to get it back and working again. Let's start by reminding ourselves of our current setup, which you're probably sick of seeing. So it's our 4 nodes, Trans Am, Cobra, Mustang, and Charger. And I've got our remote storage, which in a production environment you would definitely have. And on my diagram, I've got the backups that we did basically in a single node cluster, which was the config.db and useful files, if you recall, the critical one really being config.db. Although in a single node, we could have survived without that. As long as we had backups of our virtual machines, we could recover. But it did make life a little bit easier. In a cluster, I would argue that you absolutely need a backup of your config.db, and we'll look at that in detail in a minute. But the main reason being is you might have 500 virtual machines or more, in which case recovery without config.db is going to be a complete nightmare and take a long time. Config.db has all of your virtual machine name to virtual machine ID mappings. It's got all your users, all of your configuration. Trying to recreate that from scratch would be painful in a large environment. So you're going to back up config.db, trust me. But additionally, to make life easier, and these, we could actually get around the next bit that I'm going to say we need to back up. We could actually recreate keys and goodness knows what, but we have a cluster where there's a lot of trust between the different nodes, and this is based on a set of public-private keys, and in the case of Corosync, a symmetric key. So we're definitely going to want to back up those to make life easier. Like I say, we could get around not having them, but let's make life as easy as possible. Okay, here we are on Trans Am, and the first thing I'd like to highlight is if I say SSH to, I don't know, Charger, okay, and hit enter, I go straight in with no password. Now that means that Charger trusts root at Trans Am. And why is that? Because I didn't set any keys up. Well, that's a fundamental part of the cluster, is that the keys, which are normally stored in /root, the keys for root.ssh, are stored in a file called authorized keys. Now, if you notice, authorized keys is actually a symbolic link. In other words, what do you call it in Windows? Shortcut. Do you call them short? Yeah, you do. Pointing to etc. PVE priv authorized keys. Now, this is the same on every node in the cluster. So every node in the cluster uses the same authorized keys file. So if we were to look at that, so let's just cat authorized keys. It's going to be really boring. Plus, it's going to have keys in for my Mac Mini and things like that. Okay, so these are all public keys. I'm going to clear the screen because it's giving me a headache. Whoa. But those are all public keys of servers that are trusted by, in this case, well, the whole cluster, because there is a single authorized keys file which is shared across the cluster. So I want that. When we do our backups, I want that authorized key file. Oh, well, the good news is it'll be in config.db. So just backing up config.db has resolved one of our problems. So the next thing is, we know that there is a process called corosync, and corosync basically is our quorum mechanism synchronization, and also it synchronizes the config.db database file. Okay, so corosync is obviously very important. Now, it's actually configured in a directory called corosync. But the important thing is, if we look here, we've actually got our auth key. So if we have a look at that file, it's actually a binary file, so there's no point in actually trying to copy it. But let's just do our SSH to charger again, if I can find it. Oh, I'm still on. I'm still on charger. So let's do a checksum of auth key. Okay, let's now go back to Transam, and let's do a checksum on etc. corosync auth key, and lo and behold, they're identical. So this is what we call a symmetric key, which is used for the corosync daemons throughout the cluster to communicate with each other in a secure fashion. Okay, so we want that auth key, definitely. Okay, now if we have a look, we'll see that authorized key is going to be recovered through config.db, but we've also got our known hosts. Now, if we don't copy that file, if we fail to copy that file, it doesn't contain keys, but it actually effectively avoids us having to type in yes, do you trust this remote server? Now, if you don't copy that, if we don't get a copy of that, when you try to do anything in the cluster after you've successfully reinstalled it and reconfigured it and got all your data back, you'll find that it breaks somewhat cryptically. And it's because the cluster isn't prepared to type in yes. So one node in the cluster tries to communicate with another node in the cluster. Effectively, it's getting prompted, do you trust this server? And it's going, oh, that didn't work. Okay, but it doesn't really tell you, kind of vaguely does. It depends what you're up to at the time. But if, for instance, you tried to migrate a virtual machine from one node to another, it would fail, and it would fail mystically. It wouldn't be clear what was wrong. Now, you can get around that, okay? I mean, you could basically go in the console on each node and SSH to every other node and type in yes, at which point you've recovered and everything's wonderful. But if we copy known hosts, we avoid that complication. Also in there, of course, are our public-private key, which is id_rsa.pub and id_rsa. Now, those are our asymmetric keys that are used in public key encryption, and they're used to authenticate ourselves. So our public key is stored on every other node in the cluster, and we use our private key to prove that we are who we say we are. So those keys are critical as well. Now, again, we could get around this by updating authorized keys, etc., but we would rather avoid this. We're going to be under enough pressure. Our cluster's down. We want to get it back. And for the amount of energy required to back those up, why didn't we back them up? Well, of course, we will back those up, and everything will be a lot easier because of that. So I've kind of written what I will willingly admit is a Mickey Mouse script. So let's actually, let's get off trans, and let's get across to Kukang. In there somewhere, I have, actually I called it, put it in a directory called clusters. But in there, I have written a couple of simple scripts. And the first one, the one that we care about at the moment, is .backup. So let's I'm sorry, not .backup. It's called backup.sh. Okay. Now, this, well, in fact, let me VI that file because the color makes it a teeny bit easier to read. Well, maybe. So first of all, we're just going to take a snapshot of what the date is. I'm working on the principle that I'm going to back this up daily. But you could back it up hourly or whatever. If you're going to back it up hourly, then you need to actually add the hour to this date variable. The reason being is I'm actually going to create a directory called Trans Am Charger Mustang Cobra, followed by the date. And I'm going to make that directory, and then I'm going to go into it to save me having to continuously keep using this this particular variable, backup_dir. First thing we're going to do is actually do a backup of config.db. The next thing I'm going to do is actually change the permissions, so this actually highlights something important. Config.db is a very, very critical file. It's from a security point of view, and it has permissions of read, write, and nothing else, just for the owner. And when you do a backup, which I considered, incorrect, the backup actually has read, write, read. So in other words, it ends up giving read permission to other. And that's not a good idea from a security point of view. So I'm going to fix my backup. I'm going to copy some useful files, whatever you consider to be useful, okay? So I've kind of inferred that I'm a user on within this cluster, and I have a scripts directory, and I don't want to lose my scripts or whatever. Okay, I want to copy the auth key file, because what's going to happen is you're going to reinstall one node. So for instance, Transam. You're then going to recover config.db. So Transam now looks really good and everything looks fine. But when you reinstalled Proxmox software, you generated a new Coruscant key. And the easiest way to get that key, it is the only thing under etc. Coruscant that matters, but it's a tiny directory, so just copy the directory and be done with it. And I'm doing the same with root. There might be useful files in root that the root user has created, so let's just copy the lot. But the important thing is it picks up .ssh/root/.ssh. That's what we really need. So what I'm going to do is, after I've installed Transam, I'm going to kind of make it look the same as it was prior. I say Transam, assuming I install Transam first, I'm going to make it look identical to how it is now. And then we will repeat this process after we recover each other node in the cluster. So that's my backup script. I mean, please, it's been up long enough that you could have a look at it, freeze the screen and have a look, and use it as a basis for a properly written one. But you get the idea. The idea was not to give you a perfect script, but the idea was to give you something meaningful. So here we are at Transam in the browser. Let's log in, and let's actually go to data center, go to summary. We can see our 4 nodes are in the cluster. The cluster is called Bat Cave. It is in a Core 8 state, so everything's fine. What I've actually done is I've added some users. So I've got a user called Buck Rogers. I've got a user called Joe90. Buck is responsible for HTTP servers. Joe is responsible for apps. So I've created some groups. I've created a group called App Admins, and Joe's in that group, and Web Admins, and Buck is in that group. And I have also created some pools, and if we look at the pools, app servers, all the app servers, web servers, all the web servers. Okay, so basically all I was trying to do here was actually have some stuff that we would want to recreate. Now in a production environment, you could literally have tens of users for all the different applications that you have running on the virtual machines in your environment. So this could be really complicated and approaching impossible to recreate. So that's the added deliberate complication to make things more interesting when we do our restore. Okay. All we have to do now is destroy the cluster and then do a backup. No. Do a backup and then destroy the cluster. Let's get it the right way around, which we'll do now. The backup, I mean, not destroy the cluster. So here I am across on Kukang, and I'm in a directory called /proxmox/backups. And if we look in there, we can see that the script that we looked at earlier is in there. So let's run a tmux session. Actually, if we do a tmux list-sessions, I've actually got a couple of sessions in there. The one that we've been using for some time now is actually session 0, and that hopefully will give us 4 screens all logged into the appropriate node. I link them together, so if I hit return, I actually run a command on every node. So on the let me cd to /backups, which is a directory I have already created, and if we do a df -h of dot, you can see that this is actually that /proxmox/backups directory that we looked at a few seconds ago. And if we look in there, we'll find there's our script, and that's all that is in there. Now, if you remember, the script actually creates a directory by the name of the node that it's been run on, plus a date stamp. So let's run that script. Let's do the backup. So on every node, I'm running backup.sh, and it didn't take long at all. If this was a 9-node cluster with 1,000 VMs on it, it'd take a little bit longer, but it still wouldn't take long. So we have successfully backed everything up. So that's good news. So all I need to do now is go away and crash the cluster. I'll see you in a minute and we'll get it back again. Right, I'm back. Okay, it's another day actually. Another day, another dollar. Well, not that dollars are any use here, but anyway, that's another story. Right, so we're going to have to recover now. I have actually destroyed the cluster, so let me show you that if I can find it. So I'm logged into Transam here. There are no virtual machines, and it actually says standalone, no cluster defined. This is Charger, same story. This is Mustang, same story, and this is Cobra, same story. I'll go back to Transam. So we've got a machine, actually Transam is slightly smaller display. So here we are back on Transam, and we can see that it says standalone, no cluster defined. Right, well, let's get this recovery going. All right. Now, I have actually reinstalled the cluster, as I said before, but I've also patched it, by the way. I've updated it, so it's up to date. What have I done? I've created my alias for C. I've also logged in and checked they're okay. So one of the things that happened was, of course, it came up and said the key is invalid because the key in my known host file was for the old cluster. So I have actually fixed that, but let me actually demonstrate that. Telnet. I've just had a flashback. Let's Telnet onto Transam. Let's SSH onto Transam. First of all, it's prompted me for password, so I have not copied any keys across because I want to show you something later. So I won't bother actually going across. But if I do this, if I had, you know, that error where it says this could be a spoofing attack, somebody could be faking Transam because the key on Transam is not the same as in your known host file. The way to fix that is to use SSH-keygen and then do a -R followed by the name of the machine. So SSH-keygen -R Transam will remove any keys related to Transam or whoever, you know, or whatever you specify. You may have to use the IP address there. It depends how you SSH'd on. So it's actually fixed it by fixing my known host file. Now, you used to have to edit the known host file and delete the lines for a particular node, a particular server, but fortunately they've, in recent versions of SSH keygen, you can actually do it on the command line, which is cool. All right, so now if we go to Transam, it's actually going to say, are you sure you trust this machine? And we'll say yes. I've got to put the password in because I haven't put the keys across. I could have done that, but I decided not to for reasons I'll explain later. So if we now, I'll come out, and if we go back to our session, if I just do, I've only got one session, so I don't have to specify which session I want to attach to, and we're back in. Because these sessions, I haven't logged out of them since I last logged into all the servers. With Bash, by default, this can be changed. By default, your history file is not updated until you log out, which means these panes that we've got here all have history from the last time I worked in these panes. So if I do a search for SSH, then it actually is SSHing onto the 4 different machines, as you can see, which is cool. I need to put passwords in for the reasons previously explained, and we're on the server. And I have set an alias for C. Other than that, other than patching, setting an alias for C, desperately trying to think if I've done anything else. No, I haven't done anything else, so these are all standalone machines. So the first thing we need to do is get hold of our backups. So let's make a directory called /backups, and let's mount our share from our NFS server. And we may have forgotten, or we may not know offhand what the name is. So let's ask the NFS server what it's actually sharing. The share that we care about is /proxmox/backups. So let's mount that. So we've put mount from the IP address :/proxmox/backups on/backups. And if I clear the screen now, let's cd to /backups and do an ls. We can see that we have a backup directory for each machine in the cluster. So what we'll now do is change directory into the relevant backup for this node. And as you can see, we're now in the backups directory for Trans Am, for Charger, for Mustang, and for Cobra. The only annoying thing now is the prompt is getting ridiculously long. So allow me to actually reduce the size of the prompt. So now we have a reasonably sensible prompt. We're in the relevant directory for our backups. And if we do an ls now, we can see all of the different files. Okay, so that's cool. So let's go back to our reminder stop PV cluster. So that's the first thing we need to do. So that's a systemctl stop PVE-cluster. So systemctl stop PVE-cluster. And we can confirm that by having a quick look in etc PVE. And it's empty, which shows the PMX CFS, I've got that right. PMX CFS daemon is not running, so the etc PVE directory has disappeared. Okay, so let's now have a look at, remind ourselves what comes next. So we've stopped the cluster, and the next thing we need to do is actually recover the SQLite database. So let's go ahead and do that. And that is the SQLite command with a .restore from the backup file, followed by the .restore command and the file we'd like to restore from. And again, notice I've put those in quotes because they have to appear as a single argument to the SQLite command. It didn't explode, so looks good. So that's good. So we have now recovered the SQLite database. So let's again go back and remind ourselves what we need to do next. And it's recover the corosync symmetric key. Okay, so clear the screen again. If we look in etc corosync, we'll see that there's nothing there. Whereas if we look in, what did I call it? etc_corosync, I think. Yep. In other words, this is the copy of etc corosync. If we look in there, we can see there is actually an auth key and a corosync.conf key. So we need to copy the auth key and the corosync.conf key. We could actually copy the whole directory, but those are all that we actually need. So I'm going to actually copy those. So copy etc, well, let's do a copy -p to preserve any permissions and ownership. Not that well, auth key is obviously very strict. We will get an error message because it can't copy a directory uid.gid.d, which by the way is empty. It will fail to copy that, but it should copy the auth key and the corosync key, corosync.conf, and we'll check that it did. Okay, so that's our error that I'm not worried about. So if we now look in etc corosync, we see that we've recovered our corosync auth key and also our corosync.conf file, and also notice the permissions for auth key have been maintained as being read-only for owner, which is very important. So far, so good. Let's now go and have a look at what we've got to do next. And that is to recover the root asymmetric or asymmetric, depending on how you pronounce it, asymmetric keys, public-private key, and also the known host file from our backup and put them in /root.ssh. So we want to copy preserving the permissions, root/.ssh/everything. By the way, you could copy the whole directory if there's anything in that backup that you want to preserve. I'm trying to keep this clinical and clean and only do that which is required. So we're going to copy -p root.ssh star, which is all the keys, known hosts, etc., into /root/.ssh. So that's fine. It's what it's okay. These are things that happen. You have to sit and think, why did that happen? Right. If we look in root, root/.h, remember that authorized keys is actually a symbolic link to a file under etc. PVE. So what it did when it copied, and we're going to confirm in a second that it copied successfully, but when it copied the files across, it actually tried to make sure that the symbolic link that it was copying actually pointed to something valid. It doesn't point to anything valid because we've stopped the cluster. There's nothing under etc. PVE. Therefore, I'm not worried about that error message. So let's actually now validate that it did actually succeed in copying everything across. And sure enough, the symbolic link has been copied across despite that warning message that we got. Okay, so what do we need to do next? I think I actually moved. Yeah, we've done that. We now need to start the cluster and see whether this has succeeded or not. Very important point here. When you do a systemctl start on a process, it will start that service, okay? But that doesn't necessarily mean that the next time you reboot, that service will get started. For that to happen, the service needs to be enabled. Now, we know that PVE cluster is enabled simply because we've reinstalled the software and by default it will be enabled. But it did occur to me in the middle of the night, of course, when things occur to you, I thought, I wonder if CoroSync's enabled by default, because I'd never bothered to check before. So I've got out of Tmux simply because it will be hard to see what I'm about to show you. Let's get on to Transam. It wouldn't matter which machine, by the way. Again, we still don't have any keys. And let's do a system CTL status of CoroSync. Now, CoroSync is installed, it is configured. We can be fairly confident of that, but is it enabled? That's the important thing. And if we look here, we can see, if I can find a mouse somewhere, we can see that it's enabled. So that's good, all right? If it didn't say enabled, we would still be able to start it, which is slightly confusing if you're not used to it, but it does mean that it would fail to start after a reboot. Now notice it says start condition failed. It's an error, of course it is, but it's an expected error in a non-clustered environment, okay, which we currently are. And it failed, it says here, CoroSync cluster engine was skipped because of an unmet condition check. And that is, if I can get it right, that is condition path exists. And it's saying, does etc. corosync.conf exist? The answer was no, so it failed to start. Now it will, of course, succeed in starting because that path does actually exist. So that's all looking good. So we're going to reattach to our Tmux session, clear the screen. What did we have to do next? We had to start PVE cluster and CoroSync, and fingers crossed, hopefully we should actually have a fully recovered, fully working cluster after we've run the next command. Yeah, he said hopefully. So we want to restart PVE-cluster to get our etc. PVE back and to kick in PMX, CFS, etc., etc. In other words, to get all the cluster software working. Remember, a standalone node still runs all the cluster software. So the big difference is CoroSync. CoroSync does not run on a standalone node because CoroSync is our quorum mechanism and also synchronizes our config.db database. And in a standalone node, you don't need that. So I'm going to hit return and hope there are no loud explosions. Well, that was fairly undramatic. So the first question we can ask, is PVECM status, which is Proxmox virtual environment cluster manager status. And whoa, look at that. You could probably sense a slight relief in my voice, because obviously when I'm talking to you, I'm not really focusing properly on what I'm doing, and I was thinking this is bound to go horribly wrong, but it appears not to have done. But let's do some tests. I just thought of something. I nearly forgot. You absolutely must reboot. You must reboot anyway, because you've just reinstalled 4 machines, reconfigured them, so you need to know they'll survive a reboot. But the other reason is, if you don't reboot, you do get strange behavior. In other words, there's things that presumably are still kind of settling down. I haven't a clue why, but if you don't reboot, trust me, you'll have quirky, weirdo stuff happening, particularly in the browser, by the way. So let's do that right now. Oh, and then I'll pause the video while it goes through its reboot. So I'm just literally going to reboot all 4 nodes. Am I logged into them all? Yep. So I will come back to you with a browser and we'll see if this cluster actually has recovered properly. I'm back and I'm over at a browser. So let's log into Transam. I always pick on Transam. Oh, having said that though, he is the most powerful of these little mini PCs. And let's have a really good look around and make sure things are as they're supposed to be. So let's start off by looking, after a reboot, all of the virtual machines appear to have started. And that's because they all have the options set, start at boot, yes. And they all have started. We'll go to the console and we connect, and let me log in one of them. I'm not going to log in all of them. Life's too short, but they look fine. Well, I thought that wasn't going to log in them for a second. They look fine. So in terms of virtual machine, they look fine. Oh, we've got our storage back. Okay, Kukang-VMs, which wasn't connected to any of the standalone nodes before we recovered. Anything else worth mentioning there? Well, one thing, let's just close these down. We can see that we've got a couple of pools down here. I didn't add any machines to them. Normally you would create a pool and then go to members and add machines, but I forgot to do that, mea culpa. But let's go to data center and look at, for instance, users. We've got the 2 users I created. Actually, I created 3 users. I created John as well, but I created that previously. But we've got Buck Rogers, Joe 90. They're in the, let's move this around a bit, in the web admins, app admins, and John is in the app admins and web admins. So if we go and look at the groups, we can see we've got the 2 groups we created, and we can also see the pools that we created. So this, from having 4 newly installed machines, patched, that's pretty much all, just updated, from having 4 newly installed machines, from a fairly simple backup mechanism, which is easily scripted to back up, we restored. Now, we restored manually using a tmux session, but it would be obviously more sensible in the real world to actually have that scripted. And it would be, what, a 20-line script, including prompting for which backup do you want me to restore from, etc., etc. So it'd be very, very easy to do. What else can we check? I think that's it, really. What else can we check? Nothing really. We've got our storage, we've got our users, we've got our groups, we've got our pools, we've got our virtual machines. So it's all fine. It's all hunky-dory. This video seems to have taken me about 10 times longer than normal to actually create. I've had to do some reasonably savage editing because it was just going on forever. I was sort of adding all sorts of bits of information that when I came to review it, I thought, well, it's not really relevant. We can always add those pieces of information in a later video. But anyway, I hope you enjoyed that. So we now know how to back up our clusters and how to completely restore them. Obviously, in a production environment, you will need to test all this for your particular setup. To test it in production is going to be tricky, but I'm assuming you will have a test environment, a model office or something like that, that you can use to test these different scenarios. So Okay, well, usual rules apply. Subscribe, like, and hope to see you in the future with some more videos. My next video actually is about upgrading Proxmox, because we're on version 8 still at the moment, but version 9 is out now, and also updating, and also sort of steps you should take to protect yourself in case something goes horribly wrong. So some logical volume manager stuff. So what we'll basically do is logical volume manager snapshots, then we can do an upgrade to 9, probably be a fairly short video, and then we can roll back. We can pretend it all went horribly wrong, which it won't, but we can pretend it did. Don't forget to subscribe, don't forget to like, and I'll see you soon. Cheers all.